What's up, guys? In this video, we're going to dive a little bit deeper into our second session with Destiny. So she has a math test coming up on Friday, and she sent me over a whole bunch of work, and it's like, we got to cover all this stuff. And of course, what work do you think she sent over? Word problems. I looked at the problems. I'm like, Destiny, you got to be kidding me. Why are you giving me word problems? I'm supposed to be a tutor. I just want all the easy problems to help you with. Just joking aside, I think we can all agree we don't like word problems. So I know this is going to be a beneficial session for her. Unfortunately, she sent me everything she had and didn't clarify exactly what she needed help with. But in this tutoring session, we drill down exactly where she's kind of frustrated, what she's not understanding with the systems of equations.
It's kind of like confused. I don't know what the way to go about it.
And I try to lead her through as best as possible to prepare her for that upcoming test, which is only going to be in a couple of days. So I'm hoping we can find one more time to get together before her test, so we get pretty deep into the content. So in this video, we quickly catch up. We do a little recap of all the content she needs to know for her test, and then we dive deep a little bit more into word problems of systems of equations. I hope you can relate a little bit to this and also see ways that you can improve your understanding with word problems in systems of equations. I like this. This is something you're going to want to like follow, right? So I like this doing for everything. So, you know, because the main thing is systems of equations can get difficult. Okay. Like, you know, there's going to be 3 equations and like all this stuff. So it's nice that you're focusing on a system of 2 equations. So what that means, and the reason why I say that is like, you're going to have 2 variables. Okay. So the main idea is like to find what your variables are, what you're solving for. Okay. And in addition to what you're solving for, you know, you're going to have to write 2 equations. Okay. So that is going to be like a given that you are going to be looking for. Then the solving portion, that's going to come from, I would probably say more likely than not, you're going to be using elimination, but you know, there'll definitely be some opportunities where you'll be doing substitution and so on and so forth from on there. So, but I would definitely say the main thing that I'd want you to be able to do is like these first 2 steps. Because that's, in my opinion, that's the hard part with the word problems. Like if you can get to these 2 parts, most students, like that's where they're going to struggle from on there. Okay. All right. So this is what you already did. I like that. From there. And the other thing too, is like, remember, like when you define your variables, like that's how you can, yeah, you have your nightly stay and your meal. Sometimes you can put them in Word, you know, in like a sentence and stuff like that you'll need. So that's why it's always kind of helpful to have things defined and also to make sure that things like make sense and so on and so forth. Okay. So I'm just doing some spot checking, but do you feel like you did okay from here? I mean, it looks pretty good. I'm not sure if you're like copying down notes or if this is like,
those are notes. Those are notes.
All right. So now we get to your spot, right?
Oh, and also one more thing with the, okay, so with the parentheses 75 and 15, we got the number from Desmos. Like we graphed it on Desmos.
Okay.
That's what we did. So
okay. I mean, so that's how you're solving them, and that's fine. Like, I mean, is that okay with is that what your teacher said you could do?
Yes, but also like I also want to know how to graph it without Desmos. Like, because obviously, like it's like a line, and also for the last one, I did put in Desmos in my answer. Like I clicked the wrong place where it intersected. It gave me it gave me like a different answer from what everybody else was getting. So I just kind of want to know how to like solve it without using Desmos.
Well, I mean, you can solve it without Desmos for sure. But I mean, if you're going to graph it, I would say Desmos would be the best.
Okay.
For graphing. Just because you're going to have an X and a Y axis and you're scaling. I mean, think about your scaling. You have one that goes up to 300 and like, one, you know what I'm saying? Like that's just gonna be huge X and Y axes. Okay. You're not going to want to graph that on your own. Okay. You could, you're just not going to want to do it. Now I could show you algebraically how to solve this one. You'd want to use elimination from on there, but let's maybe save this one. We can kind of like come back to this one if this is something you want to algebraically know how to do. Okay. But I could definitely help you with that. This one, same thing. I would do this a different algebraic way to solve this. I wouldn't graph this either. I just really don't like graphing for solving. Like I like graphing for making sure to teach students to know how to graph. But as far as like solving a system of equations, I just don't think it's the best method. I would recommend an algebraic approach. So we can come back to them.
Okay.
But I would do this one substitution, and I'd do this one elimination. and I can go through those with you. All right. So, but let's go and set up like some of these, like, because obviously you didn't know how to like set these up, right? So that's just something very, very important. We got to practice. Okay. So do you want to start with number one, or is there another one that you were like?
Okay, so I would like to start on number. Yeah, I think number one was the one I was confused.
Okay. All right. So
yes, number one.
all right. So it says 3 apples and 4 bananas cost blah blah blah. 3 apples and 10 bananas cost $8.75. Find the cost of an apple. Okay. So again, what are we looking for? We're looking for the cost of the apple, right? Okay, so I would just say, like, sometimes these can be kind of confusing and whatever else. So like I would just write in like the apple cost and bananas equals apple, the banana cost. Okay, because that's where we find the cost of an apple. All right. And we also want to know what the this one's kind of confusing here because it's just asking for the cost of an apple, but technically we want to see what the bananas are going to cost as well. Right? Technically, we're just not going to solve for it. Like the two unknowns here is we don't know what the cost of an apple is and we don't know what the cost of banana is. Correct?
Yes.
Okay. So that is going to be, I would say, our two unknowns. Now, so we can say X is apple cost, Y is banana, or you can do A and B. It doesn't really matter what you want to do. So it says 3 apples plus 4 bananas equals $4.85. So if an apple cost, let's just do something simple. If an apple cost $1 and you had 4 apples, how much would that cost?
If an apple costs $1 and you have 4 apples. If an apple costs and you have 4 bananas.
If an apple costs $1, so it's $1 per apple, and you wanted to buy 4 of them, how much would that cost?
Oh, $4.
$4, right? If an apple costs $2 and you wanted to buy 4 of them, how much would that cost?
About 16.
Close. It's only $2 per apple, and $2 per apple.
8,
right? Yeah. So the point of that, I'm not trying to trick you. The point of that is, what operation are you doing with the cost per apple and the number of apples? Like add, subtract, multiply, divide. What are you doing in your head? What operation were you doing in your head to get that 8?
Probably divide.
Well, it was $2 per apple and you had 4 of them. So how'd you get 8? What did you do?
Oh, you probably like multiply 4 times 2.
Multiplied 4 times 2, right? That's what you did. So what I'm saying is, we know we have 4 apples. We just don't know what the cost is. So what operation are we going to do with X? We don't know X. We don't know it's $2 an apple. We don't. So it's an unknown, but it's going to be 4 times X. Does that make sense?
Okay.
Right. Now it says you have another apples. And then also we don't know what the cost of the bananas are. So what relationship do you think we can make for the relationship for the banana? Oh, I'm sorry. There's 3 apples. Sorry about that. I started going in the wrong direction. It should be 3x though. Does that make sense? Because it's 3 apples, right? 3 apples, and then and. So you have 3 apples in a basket. So and would be like plus, and then you have 4 bananas. Well, again, do we know what the cost of the bananas are?
No.
Nope. So that's gonna be 4. And should we do plus y, multiply by y, divide by, subtract y?
We should do plus.
Well, again, let's do another thing. Bananas. You have 4 of them, and let's say bananas cost $2. That would cost $8, right? So what operation are you doing from 4 to get to 8? 4 to.
Oh, you have to multiply.
Yeah, it's multiplying. So it's 3x plus 4y equals $4.85.
Okay.
So then the next one gives you a different relationship, but this one equals $8.75. So what relationship do you think this one's going to be? Like, what equation can you write for this one?
That one will be 3x plus 10y equals to $8.75.
Good. And then you're going to have to, then I'd solve this algebraically. Okay. Which I'll go over 2 ways to solve algebraically for you. Okay. All right. Let's pick another one out from here.
The balloons. Yes, that was it. The balloons. Yes.
Okay, so 2 balloons are in the air. Balloon 1 is 10 meters above the ground. Now, sometimes I wouldn't mind if you do have a weird, and so sometimes, when you have something like this, I'd maybe even draw like a little picture here. Okay, so there's one balloon, and it says it's 10 meters above ground. Okay, and then you have balloon number 1 is 10 meters above ground and rising at 15 meters per second. So immediately what I'm going to do is just like B1, which I think they did. Yeah. So B1, and I'm going to say that's a rate. Okay. So that's going to be a 15 meters per minute. So that is a rate that they are working at. Now, one thing that's really important about rate, whenever you have a rate that is going to equal distance, distance d equals r times t. Sorry, distance equals rate times time. I might get myself confused. So whenever I hear rate or distance and time, I always write this equation. Don't know if it's going to be used. I just always write it because it's a very important equation to know. Distance equals rate times time. So that's the rate of balloon number 1. And then it says balloon number 2 is 150 meters. Holy moly. Wait a minute. Okay, wow. So balloon number 2 is really high.
Mm-hmm.
Okay, and I'm just going to say that is 150 meters. And that one is and that's descending at 20 meters per minute. Okay, so that's actually going down at 20 meters per minute. Okay, so it's important though. This is going up and this is going down. Agreed?
Mm-hmm.
Okay. So if we were to kind of have, it might be a little different. Hey, there's your hand. It might be different. Say, it might be something to like look at it as like, let's pretend here's time and here's height. Okay. So as time goes on, like a minute, 2 minutes, and here's your height. So let's say we start at like 10 meters. Balloon number 1 is going up like this, 10 meters per minute, right?
Mm-hmm.
I'd say it kind of looks something like this. This is balloon number 1. Balloon number 2 is at 150 meters, but that's going down like that. Agreed? Like if you just kind of look at this, like what's happening like for height and time. Does that make sense at all?
Wait, so why is it not going like down? Why is it going like across?
Well, what I'm saying is this is a relationship of the height compared to the time. So this one starts, this is a graph to represent the position of the balloons. So like, let's do like 1 minute. Okay. So at 0 minutes, right? Let's say like right when we're like taking a picture of the balloons, one balloon's 150 meters, the other balloon's at 10 meters. Agreed?
Mm-hmm.
Okay. Now let's say 1 minute has gone by. Remember, balloon number 2 is going down 20 meters per minute. So after 1 minute, it was at 150, but now it just went down 20 meters, right? So now it's at 130. Does that make sense?
Yes.
Okay. But balloon number 1 is going up 15 meters per minute. So after 1 minute, balloon number 1 is at 25 minutes or 25 meters.
Okay.
Does that kind of make sense?
Yes.
Right? So at 1 meter, like let's say 1 minute here, right? At 1 minute of time, this is now at 130, and this would be at 25. Again, my thing is not to scale by any means, but do you understand what's going to keep on going? Like after 2 minutes, what's going to happen? They're going to be a little bit closer together, right?
Mm-hmm.
And it's just going to keep on going. So we're looking for this. That's what we're looking for. We want to know when are they going to meet. Oh, I'm assuming I didn't actually read the question. Write an equation for each balloon. Use the T to represent time. M represent meters above the ground. What is the exact time that the balloons will have the same height? Right. So we're looking for this. What is T? Where are they going to meet? Is the graph still kind of confusing to you?
Oh, I understand it.
Okay.
It was just waiting, like it's what like intercepting. Like
It's what?
Is it like when it's gonna intercept, right?
Yeah.
Okay.
I mean, but what I'm trying to show you is like, so this is time. This is height. Now, again, this is not going to be to scale, but let's just pretend this is at 10. And let's pretend this is at 150. Okay. So after 1 minute, we just went up to 15, right? So this is at, let's say 25, right? And then this just went down 30, right? So this is at what? 1 or 20, right?
Mm-hmm.
Okay, 2 minutes. Now what? This is going to be at 90. And this is going to be at what? 40. Are you kind of following me what's going on?
Yes, I am.
Right? And then at 3, you're going to subtract 3 again. So this is going to be at 60.
Mm-hmm.
And then this is going to be at 55. Now at 4, we're actually going to have an intersection here. At 4, this is going to be at 30. Uh-oh. So this is way down here at 30. So let's do, this one's actually going way faster. What I do is 120, 90, 60, 30. So this one's kind of going like this. something like that. And this one's going like that. Like, but yeah, we're looking for this intersection. The problem is, though, it's not going to be very nice, is it? It's not going to be like right at 3 minutes. They're not going to be the same. So that's why we have to use our algebraic approach. But anyways, like it says, so let T represent the time and M represent the meters. So they don't want things in terms of Y and M's and T's instead of X's. I would do T is going to equal time and Y is going to equal the rate plus 150. And that's balloon 2. And then to graph that, I would actually show you the algebraic method. I would show you how to graph that to do that. So I can show you how to do that from there. But I would just say, I mean, it takes time. It takes practice. It really does. This one's a little bit different, a little bit more confusing. Just
Oh yeah, the number 6 or the number 4, the one that we're on right now.
number 4.
Number 4, yeah, that's because I didn't really understand it. That's why with the graph with the Desmos one, I kind of just prefer to do it like just me solving it and then doing.
I mean, if your teacher's allowing you to use Desmos like on a test or quiz, I mean, like by all means, I'm going to show you the algebraically how to go. I mean, we have like 15 more minutes, so I want to just make sure I can cover all those. Like I only need about 5 minutes to show you the algebraic stuff. So if there's any other ones you want to help, because as I mentioned, the hard thing is like the algebra you're going to be doing over and over and over again, right? So I have no problem teaching this because you're going to know how to do this like for anything like from there. So the hard part, in my opinion, is like identifying what the equations are. So are there anything maybe on this one? And also on this one you just want to maybe do?
Number 6.
All right, fine. You picked the hard one. All right, fine. All right. So this one says Lily wants to get some granola bars at Kroger. You can get 6 strawberry and 4 cherry together for $6.90. At Sam's Club, you can get 5 strawberry and 9 cherry for $9.15. So how much is each granola bar? How much is each granola bar? Okay. So what is it we don't know? We don't know how much. That's money. And then each granola bar. Well, what were the types of granola bars we had? We had cherry and we had strawberry, right? So what are our unknowns? Let's say C is equal to the money for cherry. So I'm just going to write this quick. And S equals the money for strawberry, right? How much are they going to cost? Agreed? So again, you have 6 strawberries. So what relationship do you write for how many you have compared to the cost? We did this before. If you remember, what operation do you do?
For the cost, you do plus how much each granola bar.
So if you have 5 cherry bars and they cost $1 and they cost $3 each. How do you figure out how much? Multiply. Just remember, you're multiplying, right? So again, you don't know what they cost though. You don't, like I said, they cost $3. You don't know what they cost. All you know is you have 6 of them. So you just say 6 times the number I have, which I don't know, plus 4 times the number I have, which I don't know, equals $6.90. Does that make sense?
Yes, it does.
Okay, that's for Kroger. And then for Sam's Club, we say, oh, okay, well, I have 5 strawberry bars. How much do they cost? I don't know. But whatever they do cost, I'm going to multiply it by 5. That make sense? And then for cherry, I don't know how much they cost, but I have 9 of them. So whatever they are going to cost, I'm going to multiply that by 9. And total, that's going to be $9.15. Boom. That's kind of just like the first one. You could solve that. Let's go and look at this one. So this one says Diana purchased 6 pounds of strawberries and 4 pounds of apples for $18.90. Then she realized that this was not enough and she purchased 3 more pounds of each fruit. So that's kind of weird. So it's 3 pounds of each more fruit. So that's 3 pounds of strawberries and 3 pounds of apples. What is the cost per pound of each fruit? Okay. So here we don't know what the cost is per pound. So this is a cost, per pound. Like it's now, this is like a little bit like of a rate. Okay. But you can still solve for that, right? It's just a rate. Now, again, like if I said the cost was $2 per pound, right? And if you had 2 pounds, you would again multiply them, right? If I said I was going to buy like the number, like the apples were $2 per pound and you're like, all right, I have 3 pounds. Well, then you just multiply 3 times the cost per pound. Agreed? Okay. So that's what we're trying to find. So what is it we don't know? We don't know the cost per pound. So S equals, I'll say the cost per pound of strawberries. And then what is the other thing we don't know? For each fruit, we don't know the cost per pound for apples. Wouldn't you agree? And I'm just doing PP of apples. Now, again, cost per pound is just a rate, but you can still solve for it.
Okay.
So again, if I said I have 4 pounds of, are 6 pounds of strawberries, and let's say it's 6 pounds of strawberries and it's $5 per pound. Well, how much are you going to have to owe me? Or what operation, what are you going to do?
You're gonna have to.
Remember, listen, it's $5 per pound. Pretend I'm like a merchant at a store. It's $5 per pound. You're trying to buy 6 pounds of strawberries. How much do you owe me?
Oh, X.
Just think of like money. It's $5 per pound. You have 6 pounds. How much are you going to owe me?
30.
Yeah, 30. Now, what did you do? Did you count them up?
Oh no, I thought you meant okay. You just multiply. I thought you.
Yeah, you just multiply, right? That's what I was trying to get to.
I was
Sorry.
confused on what the.
I know it's supposed to be. It's no worries. I'm just trying to get to the point. But yeah, you're just multiplying them, right? I'm just trying not. I don't want to tell you. I needed you to just come up to it. But yeah, like if you have 6 pounds of strawberries and it's $5 per pound, you just multiply, the number of like 6 times 5, and that's going to be 30, right?
Okay.
So I need you to get that ingrained. And if I keep on telling it to you, it's not going to become ingrained. Like, so even though that was kind of awkward and probably like stressful, you're like, what? I don't know. Like you're trying to confuse me. That's not my point. I'm not trying to confuse you. I'm just trying to make sure you get this ingrained. Like, okay, I need to multiply these values because this is what I want to try to show you.
Okay.
You have 6 pounds of strawberries. Well, how much is that going to cost? I don't know because I don't know what the cost of strawberries were, right? If it was $5, you would multiply 6 times 5. But you don't know what it is. So we're going to leave that blank. We're going to leave that as S. So 6 pounds of strawberries times S, which is the price per pound. We just don't know what it is. Does that make sense?
Yes.
And then plus, now we got to do apples. We have 4 pounds of apples. Now, do we know how much apples are? No idea. If it was 2 pounds, we would multiply 4 times 2, right? If it was $2 per pound, we'd multiply 4 times 2. If it was $5 per pound, we'd multiply 4 times 5. We just don't know what the cost of what it is.
Mm-hmm.
So we're going to leave it blank as A. And again, that total cost is going to be $18.90. And then she realized, oh, that's not enough. And she purchased 3 more of your strawberries plus 3 more of the apples. Now, what do you do with the S and the A though? What operation should we do?
Multiply.
Multiply. And there you go. There's your 2 equations. Now we got to get to the solving. All right. Now there's some easy solving and there's some hard solving. But do you feel okay? Do you have any more questions?
No, I understand.
Okay, let's get into the solving. All right, and this is where we'll kind of end it off in here. First operation is going to be elimination. Now, are you familiar? You're familiar with elimination, or
I am.
Okay.
Like the move to both, move to the right, and move to the left stuff.
I mean, I'm not sure your teacher might have like a different way of.
Wait, like, can you show a description of what you're talking about? Sorry.
So elimination is just when I'm going to be like adding or subtracting the 2 equations together.
Okay.
So let me give you an example here real quick. If I had X plus 2Y equals a 5, and I had a negative X plus a 3Y is equal to a 10. Okay. Now let's pretend these are our 2 equations. If I add these 2 equations up, all right, I'm going to get a 0x plus 5y is equal to a 15. Do you see what happens when you get a 0x? That gets rid of that. Now you have a single equation you can solve for.
Oh,
that's good. That we like that, right? So this, I'll just kind of put this over here because you can keep it. That's good. We want that. That's what we want to work towards. So when we have numbers in front of our X's and our Y's, what we got to do is say, all right, I got to get rid of one of these. Now, the problem is you can't just add these together, because if you add these together, you get a 5x plus 8y equals 495. Nothing goes to no 0 happened. Do you agree?
Yes.
So what we got to do is we got to multiply by a scalar. And what we got to do is we got to get a common number. So what I always like to do is I like to find the leading coefficients of your variables that are the smallest. So that's going to be the 2 and the 3. Okay. Now, again, you don't have to do the 2 and 3. You could do the Y's if you want to, but whenever there's numbers in front of X's and Y's, you got to pick. So I always like to do the ones that are the smallest. So what we need to do is find the least common multiple of 2 and 3. So a better way to say what is the least common multiple is to say, what is the smallest number that 2 and 3 evenly divide into?
6.
Right. So how do we what do we got to multiply by 2 by to get to a 6?
You have to multiply 3 times 2 to get to 6.
Right. And what about to get 3 to get a 6? What do we got to multiply by?
3 times 2.
2. So you got to make sure you do this not just to one, but you got to do it to all of them.
Okay.
Okay. When you do that, now you're going to get a 6x plus a 9y equals, I don't even know what this is. So I'm not going to try to do the math in my head and get it wrong. So I'll just type it in 195 times 3, 585. Okay. And then this is a 6x plus a 10y equals a 600. Okay. Now,
Wait, where did the 600 come from?
2 times 300.
2 times 300.
Because you got to multiply the 2 times.
Okay.
Okay. Now we got them to be the same, right?
Mm-hmm.
Congratulations. The problem is, though, if you add them up, they're not going to be to 0. So there's 2 ways you could have done this. One, you could have picked one of these to be negative. So therefore, this would be a negative and a negative. And actually, let's actually do that. I think, in my opinion, that's like the best way to do this. So let's just make the bottom equation a -2. So what happens if I make the bottom equation a -2, because again, I want one to be positive, one to be negative. Does that make sense? Right? When one's positive, one's negative, it goes to 0. You could subtract them, but to be honest with you, most students make mistakes there. So let's just change it to a -2. So therefore, this is now going to be a -6x, right? Because -2 times 3 is a -6x. Then I actually got to make sure I got to change all of these actually. So this now is actually a -10x because -2 times 5y is -10y, sorry. And then this is a -600.
Where is it at? I can't see that. Oh, right there. Okay, I see it now.
Okay, now I have the same number. One's positive, one's negative. Now I can add them up. So now when I do that, I get a 0x. This is a -y, and this is a -15. And then you can just solve for y by dividing by -1. Y is equal to a positive 15. Now we have to be able to solve for x. So here kind of comes the annoying part of this. So y is equal to 15. Now what we need to do is we can take one of these original equations. I don't care which one you want to take. What do you want to do? Top or bottom?
Let's do the top.
Okay, so let's rewrite the top. So 2x plus 3y equals a 195. Actually, I'm going to do this in blue. 2x plus 3y equals 195. Okay, so now we got to solve for x. So what do we know? What do we know? We know y is equal to what?
Y is equals to 15.
Right. So what we can say is 2x plus a 3, and this is why I was doing this with the red, it's 15, 195. Right? Do you see where that 15 came from?
Yes, the y.
So y. Right? So therefore I have a 2x plus a 45 equals a 195. Minus 45, minus 45. Oh no, run out of space. And then I have a 2x is equal to what, a 150? And then divide by 2, x is equal to a 75. And then you got your 2 points. You got your x and your y.
Okay.
Okay. So this next one, I wouldn't do elimination here because this next one, and this is what would be my key point. Whenever you have a number, whenever you have 1 in front of like a variable, what I would do is you can just use substitution. So you know y is equal to a 15x plus a 10, right? And then you already have a y is equal to a 25x plus a 10 or plus 50. So what I would do is I would just take one of those expressions for y and plug it into the other equation. So this is what we call the substitution method. So what you do is when you have an equation that's already equal to a variable, kind of like what we did here, right? 15 was equal to y. So what we do? We replaced y with 15. Here, y is equal to 15x plus 10. So what I'm going to do is I'm going to replace this red y with a 15x plus 10. Does that make sense?
Yes.
Okay, so now that's all I really did right there is I just replaced this red y with the 15x plus 10. And now I just have to use my equations here. So now I just need to solve. So I get the variables to the same side. It doesn't really matter how you want to do this. I'm going to get the variables to the left-hand side. I'll subtract a 50 on both sides. I get a -40 is equal to a 10x. Divide by 10, divide by 10. -4 is equal to x. And then the cool thing though is, especially when you have an equation like this, is now you already have the other variable solved, right? So you already have 15x plus 10. So now I can do y is equal to a 15. What can I replace x with?
X, you can do -4.
Right, so a -4 and then plus 10. Uh-oh, crap. Plus 10, so 15 times -4 is going to be -60, plus 10 is a -50. So y equals a -50. Voila. Any questions? There's a lot we covered tonight.
Not y equals negative. What about the plus 10? We don't add the plus 10?
You could do it the other way. You could subtract 10 to the other side. I just did -50. I got the x's over to the other side. It doesn't matter. You could do either way.
Okay.
Basically what I did is I just did it one at a time. 25x plus 50. Like I decided to subtract, but you can do it either way. 15x equals a 25x minus 40, right? And then you could subtract the 25x. You just want to get the x's on the other side. So it's be negative 10x equals a negative 40, divided by negative 10, divided by negative 10. X is equal to a positive 4. Get the same answer. Uh-oh. Is it supposed to be negative 10? That's a negative 4. Did I do something wrong? That's negative 40. That's a 10x, right? Negative 10, that's a positive 4. Oh, that's a positive 40. There you go. Negative 4. So you could do it this way as well.
Okay.
All right.
Okay. Well, you're gonna send it to me. I'll figure out the question.
Okay. Yeah, just go and let me know. I mean, you can send it. I mean, shoot me an email, whatever else. And but yeah, we'll hopefully maybe we can try to connect one more time for your test.
Okay.
That'd be really cool. I think we can get that done. Okay.
Okay.